Right. Good evening, everyone. Today, I think many students are absent. There are two reasons. One is they have the exam, provincial Western Province papers tomorrow. Plus, some students they have the power cut problem. But anyway, I won't cancel the class for any reason. We are in class usual time, and so they will get the recording. Those who are unable to join, those who have got the permission. So last week we discussed up to carbon, the element carbon. And before that, I will just summarize what we discussed last week. I told you the nonmetals, most of the nonmetals are rightmost side of the periodic table, and nonmetals do not conduct electricity, and they are opposite of the properties of metals. And nonmetals can be solid or gas. So here you can see on the screen there are four non-metallic elements showing allotrophic. That means allotrophic forms of the element carbon. I told you there are two allotrophic forms of carbon, graphite and diamond. Then sulfur, this is what we are going to discuss bit in detail today. Sulfur, there are rhombic and monoclinic. And oxygen, there are two forms, O2 and O3. O2 and O3. And oxygen O2 and O3 will be ozone. Then carbon, I told you the graphite and diamond will be the crystalline forms. Graphite and diamond will be the crystalline forms of carbon. The allotrophic forms, the crystalline forms. Then we discuss, so these four elements you should know. What are these four? The elements showing allotrophic. So you can write in your periodic table the four elements showing allotrophic. These are the four elements showing allotrophic. Right, that is a bit important for the MCQs. The next one, carbon, we discuss, I think PowerPoint slide, I explain everything about carbon. And so just to summarize the table, so I have given all three, these are the three nonmetals. You should know the properties and uses bit in detail. So carbon exists as lattices, so example graphite and diamond. You can write that if you want in bracket graphite and diamond. Lattices, lattice structures, large number of atoms combined to form giant structure. Then isotopes of carbon you can write if you want with the pencil C612, then C613 and C614. So there are three isotopes of carbon. Allotrophy, you can write this existence of the same element in different forms. Allotrophic forms of carbon also you can write graphite and diamond. Graphite and diamond. If you can remember, no need to write it. Then present in the atmosphere as CO2 gas. Carbon is present in the atmosphere as CO2 gas. Percentage 0.03% by volume. And carbon is available in water. So in the atmosphere carbon is present. In water also carbon is present as dissolved CO2 in water as dissolved CO2, and in organisms also carbon is everywhere basically. In water, in example soda bottle. So what is the gas mainly present in soda bottle? In the atmosphere CO2 present, in water CO2 present, in the organisms also. In living organism also carbon is present as carbohydrate, protein, lipids, in other words biomolecules or the organic compounds. So that is as dissolved CO2, atmospheric CO2, and carbon is present in the living bodies of organisms. So therefore carbon is widely distributed in the world, and chemistry of carbon is very important. Carbon forms the most valuable natural substance in the nature, that is diamond. And if you take carbon is present in most of the fuels, therefore we can burn them and get energy, and when you burn fuels CO2 gas is given out, and even when you exhale CO2 gas is present in the exhaled air. Then burns in air produces CO and CO2. burns in air producing CO and CO2. And next, the other side I have given to make pencil rod. Uses of carbon. Carbon is used to make pencil rod. We discussed PowerPoint slide last week, right? Graphite, example graphite. To make electrodes also we use graphite. And graphite is also used as a solid lubricant. Solid lubricant. And if you take this diamond, diamond is used to make jewelries, we use diamond. And even for cutting glasses we use diamond. In addition that we use this for purification and absorption of gases, we use activated carbon, carbon nanotubes. There are many uses of carbon, right? To make black color ink. So we discussed carbon last week in detail. So just to summarize the properties and uses in this table, today we are going to discuss about the nitrogen. No need to write them. I'll use the PowerPoint slides to explain. I have given this in your theoretic also. If you take the element nitrogen, if you want to write here within bracket, nitrogen is available in the atmosphere as N2, right? As N2 gas. It's a diatomic molecule and there's a triple bond between nitrogen atoms. And 78% nitrogen by volume in the atmosphere. That is the most abundant gas in the atmosphere. So nitrogen is same as carbon. Carbon is available in the atmosphere as CO2. Nitrogen is available in the atmosphere as N2. And the other most important thing, the highest percentage in the atmosphere is it is colorless. Otherwise atmosphere will be colored, and it is odorless, so no smell. And it is insoluble in water. Like if you write very weakly soluble, accepted, and is very less reactive. So even though there is 78% nitrogen in the atmosphere, it is very less reactive, almost inert, and is colorless, odorless, tasteless, less reactive, non-toxic gas. Non-toxic gas. Even when you inhale, not only oxygen enter in your lungs, even nitrogen gas 78% enters to your lungs. So that nitrogen is not dissolved in your blood or not absorbed from your lungs to the blood. It is again exhaled. Therefore, the most abundant gas in the atmosphere is nitrogen. And nitrogen is available in the living molecules or biomolecule, example protein, amino acids. Nitrogen is present in nucleic acid, DNA, RNA, and nitrogen is also present in the soil as nitrate. So nitrogen very important, right? So nitrogen is everywhere in the atmosphere, in plants, in animals, then in the soil. You can write down if you want. I'll give a summary also later. Then what are the uses of nitrogen? Nitrogen is used to fill vehicle tires. To fill TYRES, vehicle tires. Nitrogen is used. Nitrogen is used to manufacture ammonia. What is NH3? If you don't write, what is NH3? Ammonia. NH3 ammonia and HNO3 nitric acid. What is NH3 means ammonia gas. It's a basic gas, ammonia, and this is nitric acid. Nitric acid. Nitric acid. And nitrogen is also used to fill electric bulbs. An empty space of these filament bulbs filled with nitrogen gas to provide inert atmosphere. Nitrogen gas is also used in food packaging, like empty space of milk powder packets, peanut packets. Sometimes instead of do not eat packet, that silica gel, they fill nitrogen gas to provide inert atmosphere. In other words, to prevent the oxidation of food, or else to keep the freshness of milk powder or peanuts. So in the storage, it can lose the texture and that freshness. So therefore, they, instead of normal air, filled with nitrogen gas. And it is also liquid nitrogen is used. So liquid nitrogen is very cold, even temperature is lower than even normal ice. So liquid nitrogen is used as a coolant for quick freezing of food, right? Quick freezing of food. So I will show the PowerPoint slide about this. And the other most important is nitrogen is very less reactive. Okay, so but during lightning at high temperature, means you can underline this and write high temperature means at very high temperature. That means during lightning, atmospheric nitrogen will react with oxygen during lightning. During lightning, what happens? Atmospheric nitrogen react with oxygen gas producing what? Nitric oxide, producing nitric oxide, and nitric oxide becomes nitrogen dioxide and it dissolves in the rainwater forming nitric acid, and therefore nitrogen is present in the rainwater, nitric acid. So that's why rainwater is slightly acidic due to the dissolution of CO2 and the other acidic gases. So this is what happens if I will use the summary also, I will give separately. So let's see the did finish writing. I'll show the PowerPoint slides also. These properties and uses you can easily remember with the I am using the some theory sections, small video clips and the PowerPoint slides also, and I'll give a summary note also, additional thing, right? Okay, I'll show the PowerPoint slide now. Okay, now you can see the PowerPoint slide. If you want any additional thing, you can copy down either in the theory tube or in your writing book. 78% by volume, atmosphere is filled with nitrogen gas, so troposphere, and then nitrogen is colorless, so it's American English, but you have to take is British English, colorless, so the spelling you have to change. Odorless also same thing. Tasteless and non-toxic gas, right? So nitrogen actually it's 78%. If you nitrogen is N2, it's N2. Actually in the periodic table nitrogen is Na, but it exists as N2. So there's a triple bond between nitrogen atom, that's why it's less reactive, nitrogen gas. And so it has low boiling points. You can read minus values. So both boiling point is very low. Even melting point also low. It's non-flammable. Nitrogen won't get catch fire. It is not a combustible gas. So otherwise nitrogen can be used as a fuel. So it is not a fuel. So it's not a combustible gas and will not support life. That means nitrogen. So which one will support life? That is oxygen, and is less soluble in water and slightly lighter than air. And you can write less soluble in water also. Less soluble in water, and it is less reactive. If you want any additional thing, I can copy down in your writing book, or you can add that to your theory tutor also under that table. Less soluble in water and it's less reactive. It is less reactive. So I told you nitrogen is present in everywhere, right? Nitrogen is present in your body, in living organisms, in the living bodies, and nitrogen is present in the soil, and nitrogen is present in the atmosphere, and nitrogen is present in not in the element form, but nitrogen can be present in the in water also. In the soil it present as nitrate, right? Nitrite, ammonium, like in the form of ions, ammonium ion, nitrate ion, nitrite ion, not as free nitrogen. In the atmosphere it is present as N2 gas. In the atmosphere as N2, right? So this is in the soil. In the living matter, in the living organism, nitrogen is present in the form of protein, right? Protein, then amino acids. So nitrogen is present in the living body or in living organism as amino acids. Protein, then nucleic acid or DNA and RNA, nucleic acid. So even in plants is present now, plant protein, animal protein. So nitrogen is everywhere, in the atmosphere, in water, in soil. I don't know, space I'll write here. In water also is present. How? In the same form as nitrate, because from the soil it get washed away. That's why example, one of the best example, we put ammonium and nitrogen content in fertilizers. So those nitrogen contained fertilizers get dissolved in the soil water and absorbed to the plant. And then that nitrogen is used to make plant protein. So we get plant protein, dalo, wing beans, double, beans, mungata, bonchi, like bulong, bean, mackerel. We get nitrogen from the plants as well as from animal sources. Also we are getting nitrogen, egg white, right? Fish contain amino acid protein, that's nitrogen. Therefore, my advice, don't limit only to the textbook note or its content. You should explore about nitrogen. You should have better knowledge than the others about the element nitrogen. Right, I'll erase the screen. Remember now, the students, now it is not an excuse to say cannot join the online class because of power cut. Now anyway, transport problem anyway can't help, you can't walk like long distance now. So if now the transport problem because of this energy crisis in Sri Lanka, fuel crisis, the transport, and as next part the electricity. But you have to keep your devices fully charged. If one device the charge is not enough to continue the class for 2 hours, you should have some other device, maybe your parents or somehow laptop or maybe mobile phone or whatever smart device you have to keep. Because I will not cancel the class because of power cut or any other barrier, because you are getting the exam, you get the standard paper oral exam. They will not reduce the content of the syllabus, so they will not make the paper easy because of these issues at the end, right? Sometimes they, by that time, sometimes you also forget this, right? So then please try to join on time, and then don't miss any classes. In case if you have a network problem or any unstable internet connection, you can request the recording even you join the class, because I am taking the attendance, right? So there's one student join with just the 304C. So if you are from Codex, so please remember you have to join with your first name and then the code, right? Because otherwise I don't recognize, very difficult when getting the attendance, right? Next time. Okay, so if you only can leave and join again with your first name and then the code, right, given by the institute, right? So therefore pass a message because many students are absent today. So then okay, let's see the uses of nitrogen. If you take this filament, so this is the filament of the bulb. It's if you only can make a small sketch of this diagram, even like no need to color it like line diagram, the electric bulb. Nowadays we don't use these lamps, we use LED and CFL, because this is not efficient and not energy saving, and it generates a lot of heat than light. So this filament is made of tungsten. What is the symbol of tungsten? W. That is tungsten. And this tungsten is a metal with high melting point, and it's a conductor of electricity, high resistance. So this is not this space is not normal layer, it is filled with this gas, inert gas. So this space around this filled with what gas? Inert gas. Inert means actually less reactive gas. So there are two gases mostly they use: argon, group 8 argon. One so in the exam if there's a use of argon, because argon is the third highest gas in the atmosphere. Example, hydrogen is the highest percentage by volume, 78%. Second highest gas in the by volume in the atmosphere is oxygen, nearly 21%. Third highest gas, carbon dioxide, 0.932 approximately. And the fourth highest gas by volume in the atmosphere is not actually this is wrong. It's not carbon dioxide. This is carbon dioxide is 0.03. See, he is argon. Third highest gas, argon. Next one is carbon dioxide, 0.03%. So at least the four most abundant gases in the atmosphere, you better copy down. Don't limit only to the theory, not theory too. So everyone should maintain a separate CR book, to copy down the additional notes, right? Now this is tungsten. See a tungsten filament. So this will become red hot and emit light. So inert gas, why inert gas? If this is filled with normal layer or oxygen, if oxygen is present in normal layer, the filament get burned. At high temperature, filament will react with the oxygen and filament get burned. That's why electric bulb filled with less reactive gases. Inert means less reactive. Inert means what? Less reactive. If you have any question, you can raise the hand and ask. So inert means less reactive. Less reactive. Right. Then the rest of the things not necessary, but the main thing is what I want you to learn. Remember here, nitrogen gas is used to fill what? The empty space of electric bulbs. Mixed with argon. Mixture of argon and nitrogen gas is used. Therefore, one use of nitrogen will be to fill electric bulbs. Don't forget it. If you want, you can take even a screenshot. The next one. You can see some of the fuel filling station. So these tires filled with tubeless tires filled with what gas? Nitrogen gas. They fill instead of normal air. This is filled with nitrogen gas. So what is the benefit of filling here nitrogen? Nitrogen gas less reactive. It's lighter than normal air. So this is normal air. Normal air contain moisture, water vapor, right? Water vapor, oxygen, then nitrogen also present. Then carbon dioxide, sulfur, many other gases. Therefore, the normal air that you pump to the tire contain many other gases. So those gases can react with those metal wires in the tubeless tire. I mean, it can undergo corrosion, or lifetime of the tire decreases, because at night when it's raining or when outside is cooling, then inside water droplets can be formed. Inside the tire, droplets of water drops, like early morning you can see on the windscreen the droplets of water like that. Inside the tire, water condense and form water drops. Inside the tire there can be sometimes water drops. Then it can reduce the lifetime of the tire, and then regularly you have to monitor the tire pressure if you pump normal air. And but if you pump nitrogen, many benefits. Fuel economy increase, that means you can at least run 1 or 2 kilometers extra, 1 or 2 kilometers than with normal air, because the gas is lighter than normal air, and the lifetime of the tire increases. And you can, I mean, the other benefit, you don't need to check the tire pressure regularly. The pressure is at least for about 2 months you can run the vehicle without refilling the air. So but if you pump normal air, after every 2 weeks you have to monitor the tire pressure. Otherwise, if the tire pressure is reduced, there are many disadvantages that will affect the suspension and shocks and comfortability, and tires are worn out irregular, right? So there are, but anyway, these tires contain sulfur also. Therefore pressure loss, warming up, and moisture problem can be overcome by filling the tires with nitrogen gas. In Sri Lanka also, most of the petrol shed or fuel filling station, they have put a label. Now you might have seen separate board, nitrogen gas is available, right? So then next one. So I have given here the benefits of filling nitrogen into the tires. Vehicle tires: improved vehicle handling, smooth handling of the vehicle, increase fuel efficiency. You can run bit more kilometers, so extra kilometers, because its vehicle become lighter, right? The tires become light in weight because nitrogen is less dense than normal air. Better pressure retention, that means the pressure retained for a longer period, and you don't need to refill the tire with air from time to time after every 2 weeks or 1 week. You don't need to check the tire pressure for about at least for 2 months you can use. Less irregular wears, that means you can long lifetime, extended tire life, right? And the next one, the other one, why did I put this? You can see here this empty space of peanut packets, even milk powder packet, empty space of, actually it's not empty, actually that space is filled with air. Empty space, I'll write here, then you will understand this. Empty space of milk powder packets, milk powder and peanut packets, filled with what gas? Filled with nitrogen gas. Empty space of milk powder and peanut packets filled with nitrogen gas. Sometimes they put like do not eat packet. You might have seen this do not eat packet, silica gel, that is to absorb moisture inside. Otherwise what happens? Easily fungus are growing on peanuts because of this lipid, peanut oil or peanuts, easily fungus are growing. Then you get palm pus, like that you get fungus, pus rahina. So empty space of milk powder packets and peanut packets filled with what gas? Nitrogen gas. Filled with, why? To keep the freshness of the packaged food. Filled with N2 gas or nitrogen gas to prevent the oxidation of food. Gas to keep freshness of the food. To keep freshness of the food or the food, whatever the canned food. Otherwise, what happen? It's like the freshness. When you open the milk powder packet, it's not a problem because nitrogen is non-toxic, colorless, odorless. Ne? When you buy this milk powder packet, and when you come back home, you open the packet and you put that into a bottle and close the lid, right? So when you open the packet, nitrogen gas released to the atmosphere. But after transferring this milk powder to a bottle, what happened? Then the quality, sometimes with time it decreases the quality of the freshness because of moisture present in air. That's why even in leather, packet, the box or the whatever the bag, electronic items, that maybe laptop bag, right? Even the empty space of the water bottles, kept for in the market, new water bottles. So they put this do not eat packet to overcome the moisture problem. It absorbs moisture inside the container, or else we have to replace that entire space with nitrogen gas or less reactive or inert gas like nitrogen. So those things are a bit important. These are ground nuts. I don't know how many of you have seen. You might have seen this peanut, but I don't know whether you have seen this. There's the ground nuts, right? Then next one. Again, you can see nitrogen gas in food packaging. Why? Again, this French fries or fried potato chips. So all this empty space of the canned food filled with nitrogen gas to keep their freshness. If they fill normal air, if you fill normal air contain, the air around us contain germs, even coronavirus, microorganisms, dust particles, toxic gases, moisture, many things. Therefore, you can evacuate that and fill that with less reactive gas like nitrogen to keep the freshness of canned food or packaged food. So this again. So that's why when you're going to press this from outside, it's like you feel they have filled purposely air inside. If that is not normal air, If they fill normal air, they have to put that do not eat packet, like crystals inside, like transparent. We have to be very careful if you are giving this peanut packet or whatever the potato chips or biscuit packet, if they are given to a small one, not only the content inside the food, they will eat that do not eat packet also, and it can cause even death, right? Because it's silica gel, it's a chemical substance which can absorb moisture inside. If not, you have to fill nitrogen gas, right? So then next one. Again, you can see I'm telling now uses of nitrogen. Now I told uses of nitrogen, what? To fill vehicle tires, to fill electric bulbs, and then for food preservation, in other words, to prevent the oxidation of food or food packaging, they use nitrogen gas. Even production of fertilizers. You can see what is this one. Nitrogen is used to make fertilizers because nitrogen is present in urea. What is the chemical formula of urea? It's a chemical fertilizer. Urea contain, the chemical formula is CONH2 twice. This is chemical formula of urea. This contain nitrogen. Nitrogen containing fertilizer. Nitrogen fertilizer. Nitrogen fertilizer. So this contain nearly 46% or above nitrogen should be present in the fertilizer. Otherwise, it's not good. Because nitrogen is one of the main element required by the plant growth. For the plant growth, for the other use of nitrogen, to make fertilizers, we use nitrogen. So what are the uses now? To fill electric bulbs, to fill vehicle tires, to prevent the oxidation of food, this nitrogen gas, then to make urea or chemical nitrogen containing fertilizers, manufacturing of nitrogen containing fertilizers. Then to prevent the oxidation of food, why the milk powder packet or the canned food filled with nitrogen gas? To prevent the oxidation of food. Again, you can see here in food packaging, nitrogen is used for food packaging. Why? If you fill normal air, so then it will get expired soon. Sometimes they use liquid nitrogen also in case of some ice cream or like that in making those food items very cold. Because what are the main benefit? Liquid nitrogen has no moisture, but normal ice has moisture. So then it can reduce the quality of the food. That's why the liquid nitrogen is used. The next one. So this is actually to make ice cream they use liquid nitrogen. Liquid nitrogen is used for quick freezing of food. Liquid nitrogen is used for quick freezing of food, or actually it's a very cold, like now it's minus Celsius. Used for quick freezing of food as well as and for making ice cream. Even you can search in the internet even use of liquid nitrogen for making ice cream. Liquid what is this? Liquid nitrogen. Liquid nitrogen is used. Liquid nitrogen is used in food industry because liquid nitrogen is very cold. So if you pass liquid nitrogen even into a tap line, quick freezing of maybe oil or milk. Now imagine a situation like this. So there's the pipeline. Okay, in some countries underground pipes. So in Sri Lanka mainly water. But if you take New Zealand, Australia, the other countries, what underground pipes, sometimes they pump milk because they are producing a lot of milk powder. So milk, fresh milk. Some countries underground pipes, so the oil, so continuous supply of oil. So in Sri Lanka through the petrol shed, but the other countries there's underground the pipes contain or the oil transport. So then what happens if there's a leakage, then they can very difficult to detect it because there's a wastage of oil or the milk. Then they pass liquid nitrogen, then quick freezing, it will get sealed until it is repaired. You have enough time to prevent the leakage of petrol or milk through the damaged pipes until it repaired. You can freeze it, quick freezing of oil or milk here, right, by passing liquid nitrogen, because liquid nitrogen it doesn't react with anything in the inside the pipe, milk or with oil, petrol or diesel, because it's less reactive and no problem. Once the repair is done, it will again automatically convert into gas. Therefore, there are many benefits of this liquid nitrogen also. So earlier we discussed about the nitrogen gas. So this is about liquid nitrogen. Liquid nitrogen. How to convert nitrogen gas into liquid nitrogen? So this again the applications of what? Liquid nitrogen. Liquid nitrogen. Liquid nitrogen. How to make liquid nitrogen? If you cool nitrogen gas, if you cool a gas to a very low temperature, if you cool any gas to a very low temperature, it will turn into liquid form. So if you want to write here now, it's a very cold liquid nitrogen, right? Liquid nitrogen is very cold. Temperature is minus. Right. The next one, that is sometimes what happens, quick freezing of food. To freeze liquid in damaged pipes, or additional information you can write. To freeze liquid in damaged pipes, so liquid can be petrol or diesel or even in milk, right? In addition to that, quick freezing of food. In addition to that, flush out of food packaging. To keep the freshness of the package or the canned food, they use nitrogen gas because it's less toxic, colorless, odorless, no problem. Then so that's liquid nitrogen. Then next one about sulfur. So let's see, I have given, no need to write all this because about nitrogen I have given separately here. Before sulfur I'll show you the nitrogen I have given here. So here I have given all what I have told. So the PowerPoint slide, all what we discuss, I have given the summary here. Tires to make nitric acid and ammonia, to fill electric bulbs, to prevent the oxidation of food packaging of milk powder. Then as a coolant, liquid nitrogen, quick freezing of food, we use liquid nitrogen, as well as to prevent any leakage from damaged pipes. We pass liquid nitrogen, then what happen? Milk turn into solid form, or petrol will turn into solid form then the leakage will reduce, stop. Like example, when your skin get cut, bleeding occurs unless the blood get clot. So the blood clot, that means lake at tears, so that will prevent the continuous bleeding. Now the third element that you should know a bit in detail. One more thing I'll use the PowerPoint slide now, not PowerPoint, this separate white background to explain about this nitrogen, how it reacts. So the important chemical property of nitrogen, I will use this. You can copy down this in your writing book if you want. Say what happens during lightning. Atmospheric nitrogen react with oxygen during lightning, forming nitric oxide. What is nitric oxide? The nitric oxide again react with oxygen, forming nitrogen dioxide. So what happened? Atmospheric nitrogen react with oxygen during lightning at very high temperature. At very high temperature, nitrogen gas react with oxygen. What is this called? Nitric oxide. Then again it react before in that these reactions occur during, if you're right, you better copy down if you want. This happens during lightning. During lightning, temperature of the upper atmosphere increases to a very high value, even more than 100,000 volt. At very high voltage, the temperature also become increasing. Temperature also increases between these charged clouds. So then atmospheric nitrogen can react with oxygen, forming nitric oxide. So what happened to this nitric oxide? It will again react with atmospheric oxygen, forming nitrogen dioxide. If you don't know the name, right here, nitrogen dioxide. This is additional information because anyway you will need this again when you are promoted to grade 11. So what is this? Nitrogen dioxide. Nitrogen dioxide. After that, nitrogen dioxide, it's an acidic gas. NO2 is brown color, brown acidic gas. Even from the vehicle silencer, this is coming out during the spark. Nitrogen, brown acidic gas. This acidic gas get dissolved in the rain drops. It dissolves in the rain water, forming acid called nitric acid, HNO3. What is this acid? Nitric acid. But it is not strong enough to cause acid rain. But if you release too much nitrogen dioxide, man-made one, this is a natural process, this is not a man-made thing. So then nitric acid added to the soil with the rain. So then soil contain what? Nitrogen compound. That's how nitrogen is added to the soil. That is called nitrate ion in the soil. HNO3 contain H plus and NO3 minus. So this nitrate is absorbed by the plants for their growth. Plants absorb this nitrate for their growth. Nitrogen. That's how plants get nitrogen. That's how the plants get nitrogen. Is that clear? The net nitrogen is used up by the plants to make plant protein, amino acid, like that. Okay, then I'll erase this. Next part. You better copy down this. Everyone should maintain a separate writing book for additional notes, chemistry and physics and biology. Everyone should maintain 3 separate CR books, one for chemistry, one for biology and one for physics until oral exam. One chemistry, right? Chemistry in one book, right? Then next one. Okay, that is about nitrogen. Now I gave a lot of other information about nitrogen. Third element, next element, sulfur. So there are many nonmetals, but in your syllabus only these 3 nonmetals we are discussing in detail. What are the 3 nonmetals? Carbon, nitrogen and sulfur. Carbon is a solid, nitrogen is a gas and sulfur is a solid. All 3 are nonmetals but different physical state. So let's see about sulfur. Okay, it's a yellow brittle solid. Sulfur is yellow. Nitrogen gas is colorless, ne? Carbon is black, ne? So this is brittle solid because why it is brittle? Because it's a non-metal. It's a non-metal. So it is a solid actually. Sulfur is a solid non-metal. Sulfur is what? Solid non-metal. And the other most important thing, it burns in air with blue. This is very, very important. You can put 3 stars. Sulfur burns with blue flame and emit white smoke. If you want, you can write the reaction near this S plus O2 SO2. I think many students are absent today because they have the tomorrow grade 9 exam. Government schools, they are not still promoted to grade 10. All the government schools, they are still in grade 9. So therefore, they are having the grade 9 term test, I think, tomorrow. That's why many students are absent. And again, some students having this power cut also, long hour power cut. Yeah. So anyway, make a maximum effort to join, because it's not like, when you join the session live, it's better than watching the recording. Okay, so next one, okay, you can write the reaction S plus O2 SO2. This is the reaction. When you burn sulfur in air, sulfur dioxide is formed. Sulfur dioxide also an acidic gas. It also can dissolve in the rainwater, forming sulfuric acid, that is also called battery acid. You can write here the other side, the uses of sulfur. Uses of sulfur, highlight the word sulfuric acid, write a battery acid. In front of sulfuric acid, write the chemical formula H2SO4. H2SO4, that is also called battery acid. Battery acid. Then sulfur is also used for the vulcanization of rubber. That means you can write within bracket tires, tubes. Not only carbon and hydrogen, rubber products contain sulfur. So that example you can write tires and tubes. Tires and tubes, even rubber shoes, rubber slippers, rubber products or rubber carpets contain element sulfur. That's why you should never burn rubber products around your garden, around your house. So don't let anyone to burn rubber products. Use maybe rubber band, tennis ball or toys, rubber slippers, the worn out or broken or damaged one. So don't burn, because leather items, it will release sulfur dioxide gas. It's cancerous, actually. It's a toxic gas. SO2 is toxic gas. It's a man-made gas. If you burn sulfur, this is released. Not only sulfur, sulfur containing any product will release sulfur dioxide to the atmosphere. Then fungicide, that is called Diliranashaka. Sulfur containing compounds, so the fungus not growing. So most of the skin cream for fungicide cream, Diliranashaka bath or cream or whatever, that contains sulfur. Then there's a solvent called carbon disulfide, that is CS2. What is carbon disulfide? That is CS2. You can write the formula carbon disulfide is CS2, that is inorganic solvent. Inorganic solvent, widely used inorganic solvent. Even though carbon present, we call it inorganic. That is one exception. Now I'll move to the PowerPoint slide. The things to remember about sulfur, then you will remember this easily than the text. Look at the screen. I have given now sulfur. So it's a non-metallic element found in free state, right? And it's a solid. So here's a sulfur. You can see it's available in your school laboratory, right? This sulfur is available in the school laboratory. So it's a yellow one. It's yellow brittle solid. Sulfur is what? Yellow brittle solid. Yellow brittle solid. It is yellow brittle solid. Yellow brittle solid, right? And to make rubber industry, they used to increase the strength of rubber. For making tires, they use sulfur. Even to manufacture sulfuric acid, what is the battery acid, pesticides, drugs also use sulfur. And even fireworks, here also medicines. So I'll move to the next slide. So this is what? This is crystalline forms of sulfur. What is this? Crystalline form of sulfur. Sulfur, there are allotrophic forms. Sulfur, there are allotrophic forms. So this is crystalline form. right? Crystalline form. Then next one, I'll erase the screen. This is amorphous. Right? This is amorphous. So this is also sulfur. This is what available in your school laboratory. The school lab contain this one. I don't know if they have seen. Please raise the hand those who have seen the sulfur like through your naked eye, the real appearance in the school lab. This is bottle containing sulfur. No one has seen, right? Okay, so if you burn this, it burns it blue flame, but don't burn it, because if you burn this, it releases toxic gas, poisonous gas. You should not inhale, because if you inhale that gas frequently, you can end up with even lung cancer. Sulfur dioxide burns with it goes choking smell. Choking smell. Atugagada. You should not inhale. And it is insoluble in water. So if you put this into water, it's insoluble in water. Sulfite is insoluble in water. Now this is my advice. Now remember, children, always when you're learning a subject, right? Remember what you read, what we read, only 10% will be left in our memory. So what we read, only 10% goes to our what we read, only 10%. What we hear, only 20% in our memory. What we see, 30% in our memory. What we read and see, you read and see this, then it will be around 50%. Number 5, what we say, 70%. What we say and do, engagement, that is nearly 90%. That is called engagement. This is what you should do in the school. Science means experiment. You learn it, you say that, and you do it and explain that to someone, then you remember this very well. Then this is the best method. Therefore, whatever you read like a newspaper, you'll forget it. 90% loss after 1-2 days. What you hear also you'll forget. What you see also you forget. Right? What you read and see, like you read it and see. Right? Sometimes what happened? You are going to a school. If I ask what is the name board or what the text of 2 shops in front of a school, sometimes you might not be able to. You see the board, but you don't read it. Sometimes you just see. But if you observe that, then you will remember better. So therefore, always what you do, you remember better than what you read, see, and hear. Always remember. That means when you are doing an experiment, okay, I'll give the best example. You go to the school lab, take a beaker with water and ask from the lab assistant or teacher and get some sulfur crystals and put into this. And then you observe that, yeah, it's not dissolving. You will never forget it. But you read the text in the textbook, sulfur is insoluble in water. You will forget it. You go to the lab, take a beaker and transfer some water into the beaker and put sulfur powder. You observe it's insoluble in water. You will remember that better than writing it, better than reading it, better than looking at that sentence in the textbook. I think you got the point. Therefore, always, if whenever possible in the school, like a clerk, don't from 7:30 to 1:30, don't fill notes. Encourage your school teachers, encourage the school management, and encourage your school, the lab assistant, take us to the lab and do the practicals, do the experiments, at least 1 or 2 experiments related to sulfur, 1 or 2 experiments related to carbon or sodium, like that. Then you will remember that very well. So that's why I gave this. So therefore this, but anyway, under this system it's very difficult right now. Practical physical thing is now it's going to like become digitalization, everything. In the future, again it's going to make work from home, study from home, like that thing, and get the degree also, what online degree, like something happen like that in the future also. with this situation. Right now, I can see this is the most interesting thing. The head of the matchstick. Head of matchstick. Ginekura. Have you ever thought what is the chemical present in it? Have you ever? Because everyone is using this. Head of the matchstick. So it's contain what? Sulfur. Sulfur is used to make these matches. And sulfur compounds. In addition that is skin ointments, dyes, gunpowder, we use sulfur. So to make dyes also they use sulfur. Textbook also they are given. This again the matchstick, the head is this contains sulfur and glue and many other elements. When you rub against this on the box of matches, so due to the friction it gets heated up. It gets heated up due to the friction, and then due to the heat it's ignite and produce a flame. Here can you see the match head contain what? Sulfur. This contain what? Sulfur. Sulfur is present in it. Match head. So what happened when you get a smell also, right? When you write out the message, I don't know whether you got this. You get the smell, so it's sulfur, like very small amount, because you don't do this every time. So then this gas is released from that. Or when you're doing fireworks or gunpowder, even crackers, gunpowder, so that contains sulfur compound. Sulfur compound. Here you can see the chemistry of the machine. So this box contains what? Max box contains phosphorus. Phosphorus, here red phosphorus, very important, red phosphorus. So you red phosphorus, that is easily catch fire due to the heat. When you rub the head of the matchstick contain what? Sulfur compounds. So white phosphorus or red phosphorus, extremely volatile and easily ignite. Phosphorus present in the box, and the match head contains sulfur. So then glue is used to hold the stuff together, because otherwise it will not retain in this. And when you struck on this so several times, the head of the matchstick, when you rub against the side of the box, due to the friction the surface gets heated up and ignite. So that is how even ancient time the people found the fire. So the Stone Age, due to the friction, right? Because due to the friction, even the meteorite or something, when it enters the earth atmosphere, due to the friction it get catch fire. Wildfires, Guinea. Sometimes during the dry season, due to the friction between the branches when they are rubbing against each other, then it can cause natural fire, like wildfires, right? Not man-made one. Then next one, sulfur is used to make fungicide. Here the fungicide, plant fungicide, or even you get aluham, something called aluham. This fungicide, can you see here? Now aluham is caused by a fungus. Some people get this aluham, that is caused by a fungus. So then you have to use fungicide soap. Sometimes in the market, in the pharmacy you can see fungicide soap pharmacy. So because you have aluham all over the body, then it's very difficult to apply a cream. Then doctor, so that soap bar will be more than 1,000 rupees. More than 1,000 rupees. So you should have a bath for 1 or 2 weeks with that soap, then fungicide soap. Then you can overcome that problem. Yeah, offered any question? You raise the hand. Any question? In doubt?
Yes, sir. Sir, is sulfur naturally existed in the environment?
Yeah, sulfur present in the nature in the form of free state. We call it S8, or the crystalline form available. Actually, it doesn't exist as S, or it exists as S8 molecule, right? It exists as in the form of, and sulfide also available, like copper sulfide, copper pyrus CuFeS2 in the form of sulfides, or as well as in the form of pure sulfur. It exists in the earth. Yes. Yeah. If you want, you can extract also. Yeah. Sulfur deposits available. Now you can see here again, to make dye, to make medicine. Why this the toy rubber products? Ne? Rubber toys contain sulfur because that is to increase their strength. Rubber toys contain sulfur. Rubber tires contain, due to the vulcanization, sulfur present in it. Sulfur present in this. And this one, sulfur present in this battery as sulfuric acid or battery acid. But that's called battery acid. Battery acid is what? Sulfuric acid. Now these days battery is very useful, no? So when there's a power cut, whatever. Now this is the most important thing you should understand. Electricity produced by solar power or hydropower or wind power or nuclear power or thermal power, whatever the power station, electricity has to be utilized at the same time simultaneously. You cannot store electricity in the solar panel or the power station or generator. Otherwise, during the rainy season, they can store in a factory the electricity. You cannot have, the only method of storing electricity is in a battery. So therefore, that is, the battery come from chemistry. Therefore, the batteries become UPS and power bank and all this electrochemistry. We call it electrochemistry, Vidyut Rasayana. So you will learn that. There's a very interesting lesson, grade 11, chapter 12, electrochemistry lesson. So these days, electric vehicle or hybrid vehicle or motorcycle or any vehicle, there's a battery, right? You cannot find any vehicle in the world without a battery. You cannot find any laptop or mobile phone without a battery. So battery, that is to store electricity. So that is a problem now for us. Daytime also there's a power cut, but the problem is daytime, if you have solar, you can get electricity. But the problem is how to store that, right? Because you have to you use that instantly daytime. But we need mostly electricity at night for lighting houses. So I told you the fertilizer, sometimes sulfur is used. So detergents and soap also contain sulfur. Box of matches contain sulfur. Right. So you can see many uses of sulfur. But remember, in all these, sulfur available in free form, pure form in the nature. But in all this, sulfur is not present in the 100% pure form. Example, battery acid is not pure sulfur. Okay, battery acid contains sulfur in the form of sulfuric acid. It's a compound of sulfur. That also you have to understand. Then next one, okay, that is about next part of metalloids. So then I explained about sulfur. Let's move back to the theory tube. After that, I'll come to the metalloid part. Sulfur, okay, so I explained. So this yellow highlight, this is very important in the exam. Mostly they ask about this. It's yellow solid, right? That's very important. And next one, the most important thing you have to underline, it burns with blue flame, and emits white smoke, that is sulfur dioxide. That's very important. It shows simple here, allotrophic forms S8 and is insoluble in water and does not react with acids. So it's the properties of sulfur. And the uses we discussed through the PowerPoint slides also. Now the last part of this lesson, after that the lesson is over. After this, page number 9, after that the lesson is over, but you have many questions to do. Metalloids, in single we call it loha. What are metalloids? Elements showing both metallic and non-metallic properties. Very important. Properties of both metals and non-metals. These are called metalloids. Metals between the properties of metals and non-metals. There are 5 metalloids in your syllabus. Those 5 you have to remember. Even MCQs they can ask. First one is boron. Boron is a metalloid. It shows the properties of both metal and non-metal. Next metalloid is silicon Si. Third one is germanium Ge. Next one is arsenic As. And next one is Sb antimony. Sb is antimony. What are the 5 metalloids? Boron. If you want, I'll write the group. Boron group 3. Silicon group 4. Germanium group 4. Arsenic group 5. Antimony also from group 5. These three, germanium, arsenic and antimony, no need to remember the atomic number or the electronic configuration, only the symbol and its name. But the first two you should know, even the configuration and atomic number and everything, protons, electrons, neutrons, you should know, because that is within the first 20 elements, boron and silicon. And the other one, remember, the silicon and germanium, they are actually semiconductors as well. So remember, if you only can put a stand, right? Silicon and germanium are also known as semiconductors. Not all five. Huh? There are 5 metalloids. Out of that 5 metalloids, 2 of these considered as semiconductors, right? Silicon and germanium are known as semiconductors. Are also called semiconductors. Please write it. Put a stand right at the bottom. Are also known as silicon and germanium are also known as semiconductors. Semiconductors. Ardhasannayaka is very important in electronic industry. Semiconductors. So actually conductivity between conductors and insulators. More than insulators, electrical conductivity, less than conductors. Less than conductors, more than insulators or non-conductors. That is why we call them semiconductors. So silicon and germanium are considered as semiconductors as well as metalloids, right? But out of these 5 metalloids, only these 2 metalloids you should know a little bit in detail. What? Silicon and germanium. I have given in point form their properties and how do they exist and the 1 or 2 uses. So actually silicon is very interesting. If you write it, silicon is the most silicon is the second most abundant element in the earth crust. Silicon is the second most abundant element in the earth crust. So I'll write here, second most abundant element in the earth crust. Second most abundant element in the earth crust. Element in earth crust. Please write it, everyone. Silicon is what is the most abundant one? Oxygen. Highest percentage in the earth crust, oxygen. Second highest is silicon. Second highest will be silicon. Highest oxygen. Highest oxygen. And silicon occurs in the earth crust as SiO2. That is called silica. Sand is everywhere. Sand is silicon dioxide. And silicon compounds are present even in gems. Sometimes if you go to the lab, you might have seen some of the glasswares. I'll show the PowerPoint slide that borosilicate glass. Boron and silicon both present in high quality glass, because that is not same as the normal glass that we use at home for drinking water or drinking a juice. So this pipette, burette, flask, beakers, boiling tubes, so that is called borosilicate glass, because they can stand high temperature and chemically inert. So therefore, for making glasswares, laboratory glasswares, they use borosilicate glass. And silicon, there are many other uses. So silicon has both crystalline and amorphous form. Amorphous means there's no regular structure. There is clay. Clay is silicon. Clay contain many silicon compounds. But if you take crystalline forms, quartz, gems, crystalline. That means what is crystalline means? It's a regular arrangement of the like there's a nice pattern. Irregular arrangement called amorphous form. Right. Then I will move to the PowerPoint now. The boron, actually, why are they called metalloids? Some of the properties looks like metal. Some of the properties like non-metal. Like example, high melting point, that's the property of metal. High density property of metal. But they are brittle and kind of say low reactivity. There is properties of non-metal. They have the properties of metal as well as non-metallic properties. So I have look at the screen, PowerPoint slide. use, but anyway they will never ask you to write an essay about the any of this write an essay about metalloid like that. You will never get questions in the oral paper like that, right? Okay, so I'll erase the screen. Wait, I'll use the PowerPoint slide. So anything else that you find in the PowerPoint slide, you better note down separately in the theory tutor or even in your writing book, because that will be useful for the exam. What? Actually, this third lesson, the last part, we discussed. I told you elements can be classified into three groups: what? Metals, non-metals, and metalloids. Right. Can you see the position of these metalloids in the periodic table? Boron in the middle, silicon. It's like a ladder. Germanium, arsenic, antimony. These five you have to remember. Can you see the screen? The five metalloids. 1, 2, 3, 4, 5. Five metalloid. Actually, tellurium and polonium also metalloid, but not no need under your syllabus. Right? No, only these five. What are the five metalloids? Be boron. Boron under group 3. Group 3 only one metalloid. Group 3 one metalloid. Group 4 you have two metalloids, silicon and germanium. Then group 5 you have again two metalloid, arsenic and antimony. So this is very interesting. You can see the group 4, it consists of everything. Everything means what? Group 4, carbon is a non-metal. Okay, carbon is a non-metal. Boron and silicon metalloids. Then tin and lead, what is SN and PB? Tin and lead. So this is metalloid. Metalloid, non-metal, metalloid and metals. Non-metal, metalloid and all three are there. So elements can be classified into, because most of the other groups you don't get metalloids. Say example, hydrogen is non-metal and all these are metals. So this is the only group containing all three. This is the only group contain, actually group 5 also there. So most of the groups contain either only metals or only non-metals or non-metal and metal. Only few groups containing only all three types. All three types. Right. That also you can notice that group 4 contain all three types: metal, non-metal. Right. Okay. So then 6x or probably is metal and boron is it's at the top of this. Okay. So right, that's about this PowerPoint. Okay. Then so these are the five metalloids. Can you see that clearly? These are the five metalloids. Actually, five metalloid means there are more than five. Under your syllabus, you have to remember these three: 1, 2, 3, 4, 5. Only these five. Only these five. These two no need under your syllabus. Okay. Five metalloids. What are these? Five metalloids. What are metalloids? Elements with both metallic and non-metallic properties. Right, now done. So if you don't know the spelling right, germanium GE, arsenic A, so I have given in the theory tutor also. Then next one, So this is some natural appearance of them, right, in the nature. Boron, silicon, germanium, arsenic, antimony, tellurium, no need. This is not necessary. Boron, silicon, germanium, arsenic and antimony, you remember this one not necessary. Right. Now how many of you are having the test these days, the grade 9 term test? Please raise the hand. Most of y'all I think must be from international private school, right? Are you having the exams on this, right? How many of you are having the term test these days? The school term test? Only 4 of you. So that is grade 9. I don't think any one of you are having the grade 10 term test. Grade only 5 students having the term test tomorrow. And okay, I'll write that. How many of you are having the grade? Wait. How many of you are having the grade 10 term test these days? Grade 10 term test? None of you, right? All of you having the grade 9 term test, I think. Right. Grade 10 term test. Rashmina, you have the grade 10 term test. Channel grade 10 term test. Okay. Sohan also grade 10 term test. You are from, I think, most probably from the private school, right? Okay, right. Okay. Sohan also, right, okay. Rashmina also grade 10 terms, right? Because government schools, they have the grade 9 term tests for your batch, because they will be promoted to grade 10 after this April holidays. That's why many students are absent today. They have the grade 9 work to study for this term test, right? What's your this 304? Can you unmute and tell me the name? I will rename. You are from Codex, right? Because all those who join in, so you have to put the first name, right? When you join in, you have to rename yourself, or else you can rename because you have to leave and join again, right? Okay, then next one. Silicon. So I told you the applications, so the uses of silicon. Right. Okay, Chamodi. Okay, good. Okay, because it's easy when you're asking the question. I know who you are. Right. You can see silicon very important in electronic industry, semiconductor devices, to make electronic components, to make electronic components, to make electronics. So we use this to make electronics. Please raise the hand those who are doing IT. Oh, grade 10, 11 IT. So silicon is the raw. Okay, good. How many of you are doing? Only 4 of you, right? 5. Very good. Right, good. So silicon is the raw material. Silicon is the raw material, and it's a semiconductor. You will learn this in grade 11 electronic lesson to make this electronic accessories. If you want, you can take a screenshot. You will need this in grade 11 again. So this is called diode, and this is LED. So some of the important ones on I'll tell. This is transistor. So therefore silicon is used to make electronic accessories, so computer equipment. So transistors, LED, diode, then IC, integrated circuit, or operational amplifiers. So this also a transistor, and even solar cells. They use silicon. So from where do we get silicon? Silicon is not available in 100% pure form in the nature. You have to extract silicon from silicon dioxide. That method is very expensive. You have to get pure silicon from silicon dioxide. From silicon dioxide, you have to extract pure silicon. That method is a bit expensive. That's why solar panels are expensive. Now these days, if you have solar panel with a battery, now you don't need to worry about this electricity power cut, right? So you can daytime you can directly use that solar energy, and if you have a battery, you can store that in the battery. Daytime, the production, you can store the excess electrical energy in a battery, and you can use that energy at night. So then you don't need to depend on at all uh, from the electricity supply from the national grid. But the problem is the initial cost for the solar panels bit high. So you can see it's physics, electronics under physics, so semiconductors under physics, but silicon is chemistry of silicon is very bit important. Then so silicon uses right now again. What is this? You don't know how this is not given in your textbook. Yes, who can tell me what is this? Have you all seen this gun-like thing? Please raise the hand those who have seen this. And who can tell me this name of this? You can buy this from the hardware shops also. Any hardware, if you ask this, you will. Okay, yes, often what is this? For what it is used? Often, do you know the name of this? Or for what it is used? Anyone else? This silicon tip.
Used to put, I think, gum for the glasses and all.
Yes, Avan. That is to fix, the bathroom fittings to make the fish tank. Uh, Now there can be a leakage now, so you take 4 glasses, so to fit the glasses together, so fix them. You have to uh, apply. So this normal you can't use, so you have to fix it now. Then use silicone. It's like a glue actually. So it's high water resistant, permanent one. In roofing sheets also they use this, and so that is silicon in. So it's silicon is used. So silicon compounds are used for this. I'm going to similar one here. You can see. Can you all see it's clearly? So silicon compounds are used. Waterproof. So silicon compounds are used in windows. So to make a tank like this. So they apply here. This one is applied here. Okay. Please raise the hand those who have seen this. Have you like this? Like I know the kind of you might have seen this, right? Definitely. Good. This is not given in your textbook, but it's very common, right? You know this. So silicon on application. Good. Then metalloid. So again, I have given a summary of this silicon. So even in ceramic industry, they use silicon. Semiconductor, we discussed, right? Making transistors, solar cells, computer chips, even these microchips. In cement industry, the silicon is used in the production of fire bricks also because it's heat resistant. In the exam, they will not ask so lot of uses. Maybe 1 or 2 uses and 1 or 2 properties, right? Metalloids, they don't ask. Mostly they ask questions from metals, right? Few from non-metals and stuff. This is the appearance of this pure boron, actually boron B. I don't know if they have seen this in the school. So this is about boron. That is the second metalloid that you should know bit in detail. What are the 2 metalloids you should know a bit in detail? Little bit in detail. That is boron and silicon. So this also it's shiny. That's a metallic property. And both properties of metal. Why it is called metalloid? It has the properties of both metal and non-metal. Properties of both metal and non-metal. It's a poor conductor. It's not a very good conductor like metals. You have any question?
Sir, is silicon obtained from sand?
Correct. Silicon, there are many silicon compound. One form is sand, most abundant one is silicon is extracted from silicon dioxide, that is sand. So any even clay contains silicon compound, silica, we call it silicon dioxide, and sometimes we call it silica, silicon dioxide, silica or sand. So there are different types of sand, right? Mineral sand, beach sand, like whatever clay or sand is silicon available. But pure silicon, if this method is bit expensive, that's why solar panels are expensive. So if there's a cheap method of obtaining silicon from these silicon compounds, then so solar panels you can reduce the price. This is if you if you're going to the school laboratory, check what type of glass is used to make this laboratory, measuring volume or the laboratory glasswares. So borosilicate glass, not normal glass, that is bit expensive. So the normal glass that we use at home for drinking water maybe 100 or 150 rupees. This one about 700, 600. So if you break, then it will be a bit expensive, because this one you can heat. The beaker you can heat in a tripod with the Bunsen burner. It will not get cracked. But the glass that you use at home, if you put even hot water and some, like, there can be a crack. It can get cracked or it can get damaged. So that is it cannot tolerate high temperature. It cannot tolerate high temperature. And the other most important, you can see what it doesn't expand much, because imagine the situation. If you have a measuring cylinder in the school laboratory, measuring cylinder. So measuring cylinder, it takes 50 milliliters. But actually you are going to measure slightly warm water. So then what happen? Oh, at high temperature, then the glass can expand. Then what happen? It will actually, it says 50, but you are measuring more than that because of the expansion of the glass. So borosilicate glass. So this is very borosilicate glass, very resistant to thermal shock and much more than any other common glass. That's why the borosilicate is widely used, because it has low thermal expansion, right? Low thermal expansion. So you can measure the volume accurately. Especially, I think you know about this. You might have heard about this pipette burette, right? Measure. So that is for measuring the volume. We use different glasswares, right? So that is again what borosilicate. You can see it's borosilicate. From the name itself, you can see it contains boron and silicon compounds. Therefore, in glass industry also, this is important. No? For making glass also, they use silicon compounds for making glass. So that is also, but everything not given in your textbook. Now since you all like not like, that is one benefit advantage of this with COVID and with this energy crisis. So you use like devices, right, more, and you can get more knowledge from through the internet also. But everything that you download from the internet not 100% correct. Uh, but you can use that, right? Especially English medium students, if you know the scientific term, the technical term, then you can search and get explore and get some extra knowledge, extended learning. Next one. Yeah, so what more? Yeah, that's all. Afan, you have a question to ask?
Yes, sir. How is glass produced, sir?
Actually, glass industry, it's actually you have to subject those compounds to high temperature, and you have to put them into a mold and cool it, and to you have to omit the colors, because if, it depends on the color, like some metals also sometimes use so colored compounds to get the colored glass, transparent glass, or different properties, different thickness, different hardness, different strength. You have to add some other compounds also, but it's a separate industry, so I don't have time to explain this whole thing. You can just search in the internet what raw materials are used to make glass and how it is done, like when just search in the internet and get more knowledge. So since your exam also there, I thought of discussing some questions also today under this chemistry lesson. Now let's move back to the theory too. uh, right. So that's the end of this lesson. I can start the fourth lesson also, since many students are absent. I shall discuss one or two questions. Yeah, have you done? Please raise them. Those who answer these questions, because you can get this in your term test also close. Yeah, anyone? Have you please raise them. Those who have answered at least for some of these questions. I'll be starting your paper class from most probably from either from April or May. None of you are done. The chapter 10 questions. Okay, just tell me. We'll do the first two questions. Kind of do it now, because just like 2 letters, just to fill the blanks. If you have got the hard copy, the printout, you can write here there itself. Who can tell me the answer for this one, the first one? A number of neutrons in zinc. Yes. How to find the neutrons? Mass number minus atomic number. 65 is both P and N. 30 is only P. So if you want to find N, subtract P from the total. Subtract. This is very simple. Okay. So those who are not done, quickly write the answer now. If you have not got the printout, at least you can look at the screen. Atomic number means proton. Mass number is both. So what is the neutron? How many neutrons? Yes, I'll ask the answer from. Yes, Afan. What is the answer?
35.
Yeah, very good. 65 minus 30, 35. Afan. Yeah, very good. So others also check with the answers, or else write before me 35. Next one, how many electrons? Yes, any volunteers? How many electrons are there in zinc? What is this element? Zinc. It is not in your periodic table, but it's atomic number 13. You have to remember only up to 20. But they can ask questions like this. Yes, what is how many electrons are there? What about the others? Rashmina, what is the answer? How many electrons are there? Netuli? Channel? How to find the electrons? Shamawati? Suhana? You can unmute and tell me the answer, or else. How to find the electrons equal to what? Atomic numbers, because it's
30.
yeah, very good. Yes, correct, very good. It's 30. Yes. So right, I told you, what you see, what you read, you forget. What you say, you remember better than what you read and see. Right. So if you, when you say something, because when you reply, you remember better than when you read and see this. Therefore, get the next. Next one, okay. That is how you get this one, the answer. The next one, potassium. Be careful about the plus charge. Be careful about the plus charge. Plus charge means it has lost one electron. Okay, who can tell me the number of protons? Very simple one. Because I have given the questions from the very basic, from zero. Right? I have given the questions in this from very basic questions. Yeah. Afan, yes, what is how many electrons are there, Afan?
19.
19.
Protons, right?
Sorry, protons 19. Okay, correct. Protons 19. What about the electrons, Afan?
Sir, 19. Both 19.
Not both. Both not 19. Because that's why I told you plus charge. What is the difference between K and K plus? What is the difference between potassium and potassium ion? Potassium has 19 protons and 19 electrons. Both are same, as you said. But this is K plus means what? Protons 19, electrons will be, who can tell me the answer? Why it is plus charge? Which one extra positive charge than the negative charge? That means electrons and protons are not equal. So electrons has become 18 or 20? Yes?
18.
Very good, channel. Yes.
18.
Very good, 18. Both of you are correct. 18. So now they are not equal. So one extra proton, one extra positive charge. That's why the plus charge has come. Therefore, when you write protons and electrons, especially when you write the number of electrons, you have to be careful about the plus charge. Therefore, electrons will be here 18. Electrons will be 18. Now, next one, you have to find the symbol of the element. How to find the symbol? First, look at the atomic number. From the atomic number, you can guess the symbol of the element. Which element is atomic number 6? Proton 16 means atomic number 16. Who can tell me the element here? Which element has the atomic number 16? Any volunteers? Raise the hand. Look at the periodic table. Which element has atomic number 16? The symbol. Actually, not the particle means this element, right? Yeah. Yes, or what?
Sulfur.
Yeah, very good. Symbol is S, capital S. Ne? Capital S, good. So, atomic number, you have to write this corner 16. Now, mass number, who can tell me the mass number? 16 plus 16, 32. So, the mass number is 32. And how to check whether it's neutral or charge? Now you have to count the protons and electrons. If protons and electrons are equal, then it's neutral. If these two are equal, it's neutral, but here two extra electrons than protons. Two extra electrons than protons. That means more negative charges than positive charges. More negative charges than positive charges. Therefore, what is the charge here? 2 minus. Please raise the hand those who got this answer with the charge, the symbol of this element with the charge. How many of you got? Please raise the hand. 16 atomic number, mass number 32, and the charge 2 minus. Why 2 minus? Yeah, very good. Okay, Kishwan Prageet, very good. If you only can copy this earlier also I told, if protons and electrons are equal in any atom is neutral. Neutral. Okay. If there are more protons than electrons, it's positively charged. If there are more protons than electrons, it's positive. If you don't know, write it. Positively charged. If there are more electrons than protons, it's negatively charged. It's negatively charged. Is that clear? Protons equal electrons neutral. More protons positive. More electrons negative. That's how it's example. Sodium atom. So this is sodium ion. So this is chloride ion. So that's the reason. Right. Let's see the next question now. Question number 2. So this is how most of the questions, most of the papers, they in the oral paper and even in term test papers, this is how they give the question. They don't give the real symbol. Right. Who can tell me the answer for the first one? This question is important. This is how you get mostly the questions in the term test and the oral paper also. Who can give me the answer for the part 1? Only often raise the hand. What about the others? D, how many protons? Look at the atomic number. Atomic number is equal to the number of protons. Yes, Chanul? Sohana?
7 protons.
Yes. There are 7 protons. Very good. Correct. Yes, one letter answer. How many neutrons are there in A? Okay, I'll highlight the keyword neutrons. Who can tell me how many neutrons in A? How many neutrons in A? Prageet?
5.
Yeah. Very good. 9 minus 4. Mass number minus atomic number. 9 minus 4. So answer will be 5. You can write within bracket 9 minus mass number minus atomic number. Part 3. Which atom has 8 electrons in the outermost shell? Which atom has 8 electrons in the outermost shell? 8 electrons in the outermost shell. Actually, shell, not shells. I'll ask the answer. Yes, Sohana, what is the answer?
E.
Very good. Answer is E. Very good. Very good, Sohana. Answer is E. How come E? Please look at the screen. You better write the configuration in front of each, then you can easily get the answer. So this is 2,8. This is 2,8. 10 means 2,8. So when you write the configuration, you can easily, if you don't know the configuration, that is the end of your chemistry. Okay. So when you are given the atomic number, the number of electrons, you should know how to write the configuration. So this is 2,2. This is 2,4. This is 2,4. This is 2,5. This is 2,8. So you can see these two same element. B and C same element. But their mass number different. Therefore we call them what? These two are called isotopes. Actually the atomic number 6 means carbon. So C612 and C614. C614 is radioactive. Is that clear? So they're asking, that is the answer for the next one, part 4. What are the two isotopes here? What is isotopes? Same atomic number, different mass numbers. Isotope means same atomic number, different mass numbers. So the answer will be B and C. B and C. B and C. Right. Then part 5. Shall I raise the screen? Anyone still coming down? Please raise the hand. Done. So remember, most of the, even MCQ, essay type, most of the chemistry questions, they don't give the real symbol. Either they give P, Q, R, S, O, X, Y, Z, O. They give the, ask the question indirectly, not directly. Therefore, my advice, the best thing, you should know the real symbol. Then it's easy to write the answers. Don't write the real symbol when you're writing the answer. But if you write the real symbol, it's easy to get the answer. Understood? Right. So I'll erase the screen now. There's one more. Which element would be unreactive? Who is unreactive? Noble gases. Highlight here the unreactive word. Unreactive means it should be a noble gas. Unreactive ones are mostly noble gases. So group 8 elements. So which one is a noble gas out of this? Capital E. Capital E will be noble gas. Please raise the hand those who have done this at home and got all 5 parts correct. In your chemistry, this lesson, you are good in this. Who got all 5 correct? Done this before me. At least now itself, before I tell the answer, you have done it and got all these 5 correct. At least now. Not at home, like before I tell the answer, you got it and got it corrected. Right, at least that. Okay, so very good, right? There are 5. Sohana, Prageet, Channel and Afan. Right, very good. Okay, let's move on to the next question. Try to get the answer before me. This is from the ion. This graph, this is from the ionization energy. Ionization energy. Yeah. Who can tell me? Okay, what is the first? Okay, I'll read the definition. You should know the definition of first ionization energy. What is first ionization energy? The amount of energy required, the minimum amount of energy required to remove 1 mole of electron from 1 mole of gaseous atom to produce 1 mole of gaseous ion. It's given in your this lesson, and the ionization energy definition you should know. Look at this. Here, page number 63 top. This is what you should write. First ionization energy is what? You don't write this as it is, otherwise you can't memorize word by word everything. First ionization energy of an element. Until that you don't need to write. No need to write this green one. Same, that means you are repeating the words given in the question again. So what the answer is what? The minimum amount of energy that should be supplied or required for an atom to become an ion in the gaseous state by removing 1 mole of electron. This is what you should write. The minimum energy that should be supplied to an atom to remove electron to produce positive gaseous ion. That means what? Gaseous important. Gas. Physical state from gaseous atom to gaseous unipositive ion. Gaseous atom to gaseous unipositive. Gaseous important. Atom important. Gaseous atom important. To become gaseous ion. Gaseous ion. Gaseous atom to gaseous ion. I'll tell example. Sodium in ionization energy every year all the paper and term test paper they ask. Gaseous atom is this Na G. Gaseous unipositive, dipositive means 2 plus, unipositive means plus. Nag gas plus. So look at the word I have underlined here. Gaseous atom. Atom in the gaseous state. Nag. G for gas. Gaseous ion. Na plus gas. How? By removing electron. Plus 1 electron. 1 electron is taken out. For this, the energy is required. That energy required to do this called ionization energy. Since it is for the removal of first electron, we call it first ionization energy. Since it is for the removal of first electron, we call it first ionization energy. Because to remove an electron from an atom is not that easy. Why? Because all the electrons are attracted towards the center of the atom. Because electrons are negative, the center is positive. Center is positive means what? Nucleus is positive, because nucleus has positive charges, protons. Therefore, any atom, the nucleus is positive and electrons are negative. They are attracted to each other, oppositely charged. To break this attraction, you have to supply energy. To break this attraction, to remove the electron, you have to supply energy. That energy is called what energy? Ionization energy, because energy required to become an ion. What ion? Positively charged ion. Energy required to become a positively charged ion. Is that clear? So don't memorize without understanding what it is. Ionization, this page is very important. The graph you should know, the unit of ionization. The same thing I have given in the textbook here. This one. You should know how to write the chemical equation for the ionization. You should know the definition of ionization energy, and you should know how ionization energy changes across the period and down the group, and which element has the highest ionization energy, which is helium here, and which one has the lowest, that is potassium here. Those things you should know. Highest helium, group 8 top, lowest group 8 bottom, group 8 top and group 8 bottom, highest and the lowest, highest and the lowest. Down the group decreased, across the period increase, but 6 pattern. Definition you should know. What is the energy unit of measuring ionization energy? Kilojoules per mole. And the last thing you should know, the graphical representation. This graph, they will never ask you to draw this entire graph, but part of this graph, if they give, you should know what are the elements. You should know they'll give P, Q, R, S, O, X, Y, Z, then you should know. Labeling the axis of the graph also very important, right? In the exam, if they give just 2 arrows, right? Left and left, right? So let's move back to the question now. Now, no need to repeat this again, no need to waste time on this. I showed you where it is and what is known as ionization. Yeah, what is this? You don't need to write the same sequence, in the same order, the words given in the textbook. You can give the same meaning, you can use the words you can use to give the same meaning of the definition. The amount of energy required, minimum amount of energy required to remove an electron from gaseous atom to become gaseous unipositive ion. The energy required, minimum energy required for the removal of electron from gaseous atom to become gaseous unipositive ion. That energy called first ionization energy. So what is the unit of measuring ionization energy? Kilojoules per mole. K simple, otherwise it will become Kelvin joule, right? Kilojoules per mole. Kilojoules per mole. K simple. J capital. Per mole. Kilojoules per mole. K simple, J capital. Next one, write down a pair of elements belong to the same group. Same group means what? Look at here. Ionization energy highest, group 8. Ionization energy lowest, group 1. So A and E lowest, group 1. Who are at the bottom of this graph? Group 1. Who are at the peak of this graph? Group. But this is R, is you can't take group 8. I think here 1, 2, 3, 5, 6, 7. Only 7. So this is 7th group, because you have to put one more here. This is 7th group. So you can take A and E. A and E belongs to the same group, because group 1, A and E belongs to the same group. What is A actually? Hydrogen. What is E here? Lithium. Hydrogen, helium, lithium. Both hydrogen and lithium in the same group. A is hydrogen. E is lithium. Both are in the same group. Both are in the same group. Briefly explain the reason for decrease in the ionization energy E to A. E to A means what? Down the group. Hydrogen is above, lithium is below. Down the group, hydrogen to lithium, ionization energy decreases. So why? That's what they ask. What is the reason? Any volunteers? Right. Reason for decrease in any volunteers? What is the reason? Due to the increasing of the number of shells. The distance between the nucleus and the outermost electron increase, right? Number of shells increases down the group. Then the size of the atom increase. Number of shells increases down the group. Number of shells increases down the group. Or from A, A has configuration 1, lithium 2,1. So lithium atom is larger. So number of shells increases down the group, then size of the atom increase, then size of the atom increases, size of atom increase, and attraction of the electron towards the nucleus less, because when atom become larger, outermost electron held more and more away from the nucleus, from the center. Attraction less attraction with the increase of the size of the atom. Size of the atom increases and attraction decreases. Size of the atom, then the size of atom increases and attraction of the electron decreases. Less attraction means less energy required. More attraction, more energy. The small atom, electron is very close to the nucleus. Very difficult to remove. A lot of energy required. Large atom, easy to remove the electron, because large atom means electron is held away from the nucleus. Less attraction, easy to remove. More attraction, difficult to remove. More attraction in the small atom. Less attraction in the large atom. Large atom, more reactive. Potassium at the bottom, highly reactive. Easily lose the electron. Largest atom, potassium, lower ionization energy. Less energy required to remove the electron. Understood? Right. Then next one. Write down the ionic equation which represent the first ionization energy of O. Actually, E is lithium. Don't write the real symbol. E, gas, gaseous atom, remove 1 mole of electron and become E plus gas. E plus gas with the removal of 1 electron. Understood? Right. Is that clear? Okay, I'll erase the screen now. MCQs. Shall we do about first 5 MCQs? Who found the neutron? Any volunteers? Who found the neutron? This theory tube, this same tube, the first page. Look at the table. Who discovered the neutron? Any volunteers? Yes, Afan?
Second answer.
Yeah, very good. Correct. Answer is second. James Chadwick. Very good. Who introduced the atom to the world? It's a Greek. He was a Greek philosopher. I don't know whether it's given in the textbook. A Greek philosopher introduced the term atom to the world. Atomos means invisible, indivisible. It's a Greek word, atomos. So it's originated from Greek. It's a Greek word. Now we use in English atom. Yes, Amfan?
Second answer, Democritus.
Very good, excellent. Yes. Answer is second, Democritus. You can search in the internet. Who introduced the term atom to the world? Answer is Democritus. He was a Greek philosopher. Atomic number is the third one. Any volunteers? What about the others? So the Rashmina, Prageet, Netuli. What is the answer for the second one? Kishon, Chanul, Chamodi. Third MCQ. What is the answer? Vishwa, Sohana.
Number of protons in the atom.
Very good, correct, Sohana. Number of protons inside the nucleus of an atom. So the answer is atomic number is the number of protons, nothing else. That is the definition. Fourth MCQ, who can give me the answer? Any volunteers? Fourth one, Abdullah, yes. What is the answer for the fourth?
So atoms have different masses of same element.
Atoms of different masses of the same. Yeah, correct. Atoms of the different masses of the same element. Different masses means different mass numbers, the same element. Same atomic number of same element, bro. That the perfect one is first answer, right? Atoms of the same masses, different atoms of the different masses of the same element. Atoms of different masses of same element. Answer is fourth. Yes, answer is fourth. Atoms of different masses of the same element. You can't tell different element. Same element means what? Element is carbon. Same element, carbon. But mass numbers are different. This one say 12, this one is 30. Different masses, but the same element. Different masses, 12 and 13, but the same element carbon. Atomic number same, 6. That's why the same element. Answer is 4. Question number 5, who can give me the answer? 5th MCQ. Lightest particle in an atom. What is the lightest particle in an atom? Yes, Abdullah, Prageet.
Sir, electron, sir. First answer.
Very good. Correct. Lightest particle, electron. That's why when you take the mass number, the mass of electron is not considered. We consider only the mass of protons and neutrons when taking the mass number. When considering the mass number, we take only the mass of proton and neutron, not the electron. 6th MCQ, any volunteers from question number 6? Not constant to a certain element. Abdullah? Suhana?
Sir, number of neutrons.
Very good. Because of isotopes. Very good. Answer is number of neutrons. Write the reason, due to isotopes. Same element, but neutron number is not constant due to isotopes. Very good. Question number 7. Any volunteers? Maybe you might have not done this at home, but at least now look at the question on the screen and tell me the answer. So then your thinking ability is improving. Any volunteers? 7th MCQ? Yeah, Abdullah?
Sir, fourth answer. Protons and neutrons.
Yeah, very good. Because electron mass is negligible because electrons are very light in weight. Therefore, the mass of the electron is not considered for the mass number. Oh, yeah, very good. We'll do only up to 10. Only these two. Which of the subatomic particles equal in mass? Which pair are equal in mass in an atom? Which subatomic particles are equal in mass approximately? What about the other students? Rashmina?
So protons and neutrons, sir.
Chanal? Chamadi? Afan?
Protons and neutrons.
Yeah, very good. Protons and neutrons. They are equal in mass. Approximately equal in mass. 9th MCQ. After this, I'll stop. Any volunteers? 9th MCQ. 9th MCQ. Yes, Prageet. Abdullah.
Sir, one, sir.
First answer.
Very good. All of you are correct. Excellent. Very good. The last one, 10th one. After this, I'll stop. 10th MCQ. You can check how many correct those who have done it now at least and put the answer before me. Afan, what is the answer for the 10th MCQ?
Sodium. Yes. Group.
Group are the answer. Yeah, which group? Channel?
Group 1.
Very good. Group 1. So it belongs to group 1 because almost 1 electron. If electronic configuration ends in 1, group 1. If configuration ends into group 2, like that. So please raise the hand. All 10 correct. All 10 MCQs correct. 10 out of 10. Before me, I did this and got all correct. If so, raise the hand. Before I explain this. Afan, Abdullah, very good. Right, correct. All 10 correct. No, okay, good. Because this is chemistry, the beginning, right? The historical background of chemistry and basic things about subatomic particles. Please complete. Now those who are having the science paper within next week or maybe tomorrow, like I don't know, your school timetable, the private schools. So please try to do this, all the questions. That will be a good experience before the exam if possible, because third lesson, very good revision. You can do this at home, right? So next week then I'll start, because since many students are absent, I didn't start the 4th lesson today. Next week I'm going to start this one. Within 1 day I can finish this. Actually sometime 5th lesson also I'll finish. This is very short lesson and we can finish this within 2 hours definitely. Next week I'm going to start this, right? So therefore I will not cancel the class because of power cut or any reason. I am well prepared for that. You also should be well prepared to continue for 2 hours even with the power cut. You should not make that as a barrier for your education, right? Okay, we'll stop for today. Good night and God bless you all.